So students, let us see this question. This question says the stiffness C of a spring depends on core diameter D. This is the core diameter as you can see in this diagram. This is the core diameter of the spring. On the wire diameter small d, see this is the diameter of the wire and this is represented by small d. On the number of turns n, small n, and the material parameter that is the g, the insertion module, G is called your insertion module. The following applies. So the formula for stiffness of a spring is C is equals to D G into D raised to power 4 upon 8 N into capital DQ. In the case of a second spring made from the same material, now please see if the material is same, if we have the same material, it means g, this capital G will be same for both the springs because this is the material constant and this is same material, so G will be same. And with the number of, with the same number of turns, it means this small n is also same for both the spring. Both the core diameters and wire diameters are half. So now this is saying that the core diameter, that is the D is going to change by D by 2, and the wire diameter, that is a small d, going to change by half of the initial value. So what will be the change in the stiffness of new spring? Let us suppose this is a CD. So this is a very simple question. So in this formula, if we ignore the constant terms, see this capital G is constant, this small n is constant, obviously this 8 is also constant. So what is the relation between these variables? So it should be C should be proportional to small d raised to power 4 upon capital D raised to power 3. So if we apply our simple mathematical rule, the concept of proportionality, if we write C1 upon C2, or we can write C upon C dash, or we can write C dash upon C, right? If we write C dash upon C, so what we can write? See, it is directly proportional to small d raised to power 4. So we should write small d upon small d dash upon d raised to power 4 into, this is inversely proportional to capital D raised to power 3. So it should be, since we have written C dash upon C and it is inversely proportional, so here we will write D cube upon D dash cube. Or we can write combinedly like this also. It should be D dash, no, it should be D upon, it should be D upon D dash raised to power cube. Let us understand one more time. See, since C and small d are directly proportional, if I have written C dash upon C, so this side, the same pattern D dash upon D and the power 4, since the rule is power 4, the proportionality is going with D raised to power 4. Now this C and capital D are inversely proportional. So if I have written C dash upon C, so in this side you have to write in reverse manner. It should be D upon D dash and the power will be 3, right? So let us see C dash upon C should be equals to D dash is, see this is my new diameter, that is the D dash. So D dash is D by 2 and the initial diameter was D raised to power 4 into the initial diameter capital D, the core diameter, and this is the new diameter, that is we can say D dash is D by 2. So please write D by 2 raised to power 3. So if you simplify simply, this D and D will cancel out, this D and D will cancel out. So we are getting C dash upon C should be equals to 1 by 2 raised to power 4 into, this 2 will go in numerator into 2 raised to power 3. So if you simplify this, you will get C dash upon C should be equals to 1 by 2. It means C dash is equals to C by 2. So the new stiffness will be half of the original stiffness, right? I hope you have understood this question. Thank you. Thanks for watching.